Hello viewers, today we are going to discuss the moment of inertia of an unsymmetrical I section. In the previous video presentation, we discussed moment of inertia of channel section. Okay, so let me go into the presentation. So this is the problem. An I section has top flange 90 mm by 20 mm, while the bottom flange is 180 mm by 15 mm. If the web thickness is 20 mm and overall depth of the section is 160 mm, obtain the moment of inertia of the section about the x-axis and y-y axis. So I hope now based on the previous video, you are all familiar with how to calculate centroid as well as moment of inertia. What is the formula we are going to use, right? So let's see this problem. So in this problem, the question is, that is the drawing is not given. Instead of drawing, there is a statement, there is a dimension is given in the text format. Okay. So based on this dimension, I am going to draw the unsymmetrical I section. Why it is unsymmetrical I section means, see the top flange dimension 90 by 20 mm and the bottom flange dimension is 180 by 15 mm. So the bottom flange dimension is higher than the top flange dimension. Okay. So now I am going to draw the I section. Okay, so this is top flange, this is bottom flange, and this is web portion, the vertical portion called as web portion. So this I section is symmetrical about YY plane and unsymmetrical about XX plane. Okay, why I am choosing this problem means, if it is a symmetrical in both the axes means you may solve. In the previous video lecture, we can use some alternate way to find out the moment of inertia for the channel section. Okay, so the same procedure you can use for the symmetrical I section. In tutorial problem, you can solve that problem. Now I am going to solve this unsymmetrical I section. Okay, so in the problem, the top flange which is given, the size of the top flange is 90 by 20 mm. So this is 90 mm and the height is 20 mm. All dimensions are in mm. And the bottom flange is 180 mm by 15 mm. This is 180 mm and this is 15 mm, 15 mm. Right. And web thickness is given, this is web portion, web thickness is 20 mm. And here overall depth is given, not web depth is given. Web depth means this is web depth actually. This is depth of the web. But in this question, overall depth of the section, the overall height of the I section is given, that is 160 mm. And what is the depth of the web? You can 160 minus this height minus this thickness 15. This thickness 15 mm. 15. So 125 mm is the depth of the web. Now I am dividing this section into three parts. This is my section 1 and this is section 2 and this is section 3. Okay. As usual, you can calculate the x bar and y bar value. This is x axis, this is y axis. So I already told this is symmetrical about y plane, right, and unsymmetrical about x plane. So symmetrical about y plane means x1 equal to x2 equal to x3, which is equal to x bar. All the centroid points are in the same line. Okay, because you are taking from the extreme left first section centroid, from the extreme left second section centroid, from the extreme left third section. Please don't take it for first section from here and second section from here and third section. That is not like you need to take a common reference line. Okay, so that's why the x1, x2, x3, x bar equal to 180 by 2. The total width is 180 mm. That is 180 divided by 2, which is equal to 90 mm. Right. And y bar you need to calculate using the formula a1 y1 plus a2 y2 plus a3 y3. Okay. So a1 is the 90 by 20 is the a1 into y1 from the bottom. What is the centroid of this height? From the bottom, what is the height? That is the y1. Okay. So y1 is, so this is 15 plus 125 plus 20 by 2. How will you calculate the y1 means? First this one 15 plus this height 125 plus half of this height 10 mm, 150 mm. Otherwise you can calculate like this also. The overall depth, you know the overall depth. So 160 minus this height. This is half of the 20 mm. 160 minus 10, you will get 150. Both the way you can use. Either you can add from bottom, first section, third section, second section, and half of the first section. Otherwise, you know the overall depth means you can minus the half of the first section height, thickness. Okay. So you will get 150 mm. So 150. Plus A2, this is the web portion second section area. So 125 into 20 thickness of the web, height of the web, into centroid from bottom. Okay, how will you calculate the centroid from bottom? So first you take the half of this height 125 by 2 plus 15 mm. Please don't 125 plus 15. So 140 divided by 2, that is wrong. Okay, so you just take the half of the centroid of the individual section plus add this. Why you are adding this means you are taking from the bottom. That's why I am adding this thickness. Suppose I am taking from here means just 125 by 2. Okay, so 125 divided by 2 plus 15 mm. So 77.5 mm. Okay, 77.5 plus the third section is 180 by 15 into centroid 7.5, 15 by 2, 7.5. So here from the bottom 7.5. Okay, divided by 90 by 20 plus 125 by 20 plus 180 by 15. This is the total area, that is A1, A2, A3. So the y bar value, it comes around 16, I calculated, it comes around 69.142 mm. So y bar, which is equal to 69.142 mm. So this is y bar and this is x bar. Okay. So next, I am going to calculate the moment of inertia about x axis. Moment of inertia about x axis. So you know the formula here, three sections are there, section 1, section 2, section 3. So Ix is equal to Ix1 plus Ix2 plus Ix3. So Ix1 equal to A1, sorry, B1 D1 cube divided by 12 plus A1 into H1 bar square. You know the H1 bar, Y bar minus Y1. Okay, similarly Ixx2, Ixx3, right? So I am directly, we discussed lot of problems related to this Ix finding the moment of inertia. I am directly write the numerical values here. So Ixx, which is equal to B1. So just let me tell you, B1 is 90, D1 is 20, B2 is 20, D2 is 125, B3 is 180 and D3 is 15 mm. Okay, right. Let me write B1 90 by 20 cube divided by 12 plus 90 into 20 into H1 bar square, that is Y bar minus Y1. You know the Y bar 69.142 minus Y1 is here. So this is Y1. Okay, 150. 150 is whole square. Okay, plus second section B2 20 by 125 cube B2 D2 cube divided by 12 plus 20 into 125 into H2 bar square. H2 bar means Y bar minus Y2. 69.142 minus, so this is 77.5 is the Y2 value. 77.5 the whole square plus B3 180 by 15 cube divided by 12 plus 180 area A3 180 by 15 into H3 bar square. H3 bar is the Y bar minus Y3. 69.142 is the Y bar minus Y3 is here 7.5. Okay, 7.5 the whole square. Okay, so according to the formula I expand this equation. Okay, so from that you need to calculate the Ix value for every section. Finally you can add all these three sections, you will get the moment of inertia of the I section about X axis. So I have calculated the Ix value, that is for first section is 11.828 and for the second that is 90 by 20, first section is 11.828, second section web section 3.429 and third section this one 10.309 into 10 power 6. You can sum of all these three things, you will get 25.56 into 10 power 6 mm power 4, 25.566 into 10 power 6 mm power 4. So the Ix value 25.566 into 10 power 6 as per my calculation. Right. So next I am going to calculate the moment of inertia about YY axis. Moment of inertia about YY axis. Right. Okay. Here, so see the problem. So here we already mentioned x1 equal to x2 equal to x3 equal to x bar equal to 180 by 2. That is all the centroids of the I section, that is individual centroid of the I section and the centroid of the whole I section, all are coincident in a same line. Okay, here the x bar, that is h1 bar term will neglected, because you know for this IYY what is the h1 bar? X bar minus x1. So x bar value also 90 mm and x1 value also 90 mm. So 90 minus 90 is 0. You can just put d1 b1 cube divided by 12 plus d2 b2 cube divided by 12 plus d3 b3 cube divided by 12. h1 bar x bar minus x1 0, that is 90 minus 9 is 90. h2 bar x2 bar x bar minus x2, that is also 0, and h3 bar h bar minus x bar minus x3, that is also 0, because all x1 x2 x3 and x bar value are same, all centroids are pointed near same line. So the h1 bar, h2 bar, h3 bar value becomes 0. Okay. So for that I am Iyy, which is equal to d1. You know the d1 is 20 mm, b1 is 90 mm, d2 is 125 mm, and b2 is 20 mm. D3 is 15 mm and B3 is 180 mm. Okay. So which is equal to 20 into 90 cube divided by 12 plus 0 plus, why 0 means area into h1 bar square. h1 bar square is the x bar minus x1, it is 0. Okay. Plus 125 into d2 b2 cube 20 cube divided by 12 plus 0 plus 15 into 180 cube divided by 12. So the Iyy value is 8.5 8.588 into 10 power 6. Iyy is equal to 8.588 into 10 power 6 mm power 4. So that's it. The problem is over. So I have calculated Ixx, x bar, y bar, Ixx, Iyy. Okay, right. So up to this, today's presentation we have discussed, right? We have discussed angle section, P section, channel section, and today's presentation I section. Okay. So up to this, moment of inertia is almost over. So for your exam point of view, this is enough, and we need to see on some little bit cut section like problems in the next video presentation. Okay. So I will give some tutorial problems to you. You can solve it and scan the document and upload it in Moodle. Okay. So thank you all. Thanks for your attention.